Welcome to Warblog. This is an unusual video in that it's just an update on a bug report, so to speak. In the last game we played this scenario in which they attacked this unit here and these two units were not getting their bonuses. Now I just feel like explaining this because I had another area which I actually resolved, which was something that was not really me, but this area was sort of me, and it's quite particular, and I just feel like just explaining it really. Essentially, I don't want to say it's not major. It wasn't major. It was just a very insignificant oversight, but it's major in the sense that essentially it's probably been going on forever since irregulars got their bonuses, and that's why I feel like talking about it, just to sort of make sure I've covered it verbally. So essentially the situation was when these two units are stacked up, they should be work defending 4. But what it was doing, it was choosing these units, and then it was running through a query that ran through these units. But the actual value was from another query that was very, very similar. And because that query was very similar and it was all the same value, and that query wasn't being run, it was a static value, which in this case happened to be 3. That static value happened to be 3. So it ran through it twice, and both times it pulled out the static value of 3. 3. Meaning 6. So these units would not have got their bonus. And so basically what I've done, I've adjusted that so it's actually using the proper loop. So it's going through and it's counting 3, 1. So just to put it into perspective, it could have been that the static value was 2 and it would have counted this up as 2, which instantly would have been right. Now the reason it's been so difficult to spot, or hasn't been spotted up to now, and it's probably been going on for a while, is because you generally don't attack stacked units. You generally only attack small units, but the thing is, if for example the static value from some other query loop, and it would be quite difficult to get this, so you'd have to have something very, very particular. I can't even imagine how you would have it, because it's in the combat system. So basically it would be very unusual to have this, but if the static value had been 7, this would have gone through and it would have gone 7, meaning 14. You think, wow, how could they possibly have that? So anyway, I've sorted that. So basically, if we were to attack now, and what I've been doing, it's actually quite easy. I'm going to start up another game. Doesn't take long. So it was repeatable, and that was the interesting thing about it. So if I move this unit, as far as I can get from there, and then this unit here. This was what interested me. It wasn't sort of a bug that was random. It was always there. If I do this now, I'll get the correct value. They'll be defending on 4, so I'll get my 15. So it should be basically, because I've got a surround of 10, so it should be 16.5 versus 4. 16.5 versus 4, so that's correct. What it was doing before, it was saying it was 6, as I've already explained, because it was adding this one up twice, basically. I think that's where the static value comes from, the first unit. And it's probably been doing that for years, but because we haven't doing any sorts of, attacks, irregular attacks on stacked units, and where I have been doing irregular attacks, for example, if I had 2 of these stacked up together, it would go through it, it'd count this one, and then it would count this one again, but 1 and 1 equals 2, and so it would appear to have exactly the same value, so you wouldn't notice. It's just because in this one, because we've got 1 significantly higher. I really don't like bug checking because it can go on forever, but the thing with programming is it's really enjoyable, and one of the things I really loved years and years ago was maths, And it's a strange thing. I always remember that because it's important to understand and know that maths is enjoyable. I used to enjoy doing quadratic equations because when you solve them, you get a sense of, well, I don't know what it is, a sense of satisfaction and pleasure, so to speak. And it's interesting and I think important to notice that because not a lot of people will understand that. And you know, especially when you consider, you know, how the mind works and how certain people's minds work, and if you're sort of thinking, well, what is it with me, one way or the other. I mean, for example, a war game is you know, a war game, but it's not too far dissimilar to maths and to a lot of other disciplines, just number crunching, for example. You know, some people can enjoy that, things like Sudoku, but, you know, so the thing is, if, you know, maths can be quite complex, and I think it's the complexity that mounts up. I mean, if someone said do this simple task repeatedly, although you might need a little bit of thinking, you know, because it wouldn't be as enjoyable, but, you know, complex maths is relatively simple in that regard. You know, solve these 10 quadratic equations you know, using fairly sort of complex logic would be entertaining and pleasurable to some extent. If it took you, you know, 5 hours to do each one, probably not. But you know, the rules for dealing with quadratic equations are such that it's beyond the scope of a lot of people to pick them up and understand with them and run with them. But they can understand the rules for Sudoku. I always use Sudoku because it's quite sort of one of these moreish games. You start playing it, you want to play more of it, but it's like a lot of little games. And I think you know, understanding that sort of pleasure is key to understanding why people might enjoy war games, and why I think is key to understanding why a game like this works. I mean, a lot of people play other war games, and they're more sort of real-time strategy, and there's just no, you don't think like that. And a lot of the other games that are almost similar to this, but are far more complex, are still very, very different because the concept of the logic is beyond your ability to comprehend it, which means it's more of a black box as opposed to this, where you should, in theory, be able to extend your mind far enough to say, well, that's going to be 3 plus 1, 4. In the open, there's going to be no variables on that. Here, we should be able to understand these irregulars, 1, 2, 3, they're going to get up to 5. You know, so those sorts of things are all you need to know, in the sense that those are the factors that are relevant. So, but the point I'm making here, along all those lines, is that having solved that problem, having solved this issue, I feel quite good. You know, and I loathe to do it because from time to time it can take me hours. You know, I could be there for 8 hours, and it's that dread of an 8-hour haul just opening up this problem. This one, it took me probably about 20 minutes, and I was just sitting there thinking, this is just one of those things I just cannot resolve. And what is it? It's just, you go through, well, I go through this sort of tendency of thinking, but that's not possible. There's absolutely no way that can be happening. And you quite often get this sort of, you know, stubbornness of, this is impossible, it can't be happening, you know, and then you realise, well, actually that's a very subtle error. And I solved it, and therefore it was an error and it was happening. But that's that really. So I thought I'd just add this video because I thought it was quite useful to sort of get to that stage. Yeah, so that's it. I'm not even going to say I hope you enjoyed that, because it's just I hope you really appreciate the mechanics of my mind a little more after looking at that. I'll speak to you later. Cheerio.